Assalamu alaikum, hope all of doing good. Today's our topic is going to be basic operations of digital electronics. So a switch has only two possible states. It can be either open or closed, as well as such things which can have only two possible states are known as binary variables. The state of binary variables are usually represented by the digits O and 1 as well as in them. So suppose we form a circuit by connecting a lamp to a battery using a switch 5. We call state of switch as input and state of current as input as output. When the switch is open, no current passes through the circuit and lamp is off. In other words, it possesses the outputs as well as inputs by which they get the acknowledgement. By which we get the acknowledgements of them. When input is 0, output is also 0. When a switch is closed, current passes through the circuit and lamp is on. Thus, the output current is also a binary variable. In case the current is passing, we can say the value of the output is 1 and it is 0. When no current is passing, the possible combination of input and output states of these circuits is that these states are called logic states or other states in them. These states are also called logic states or logic variables. Now the questions arises that if the values of the input variables input, we get the acknowledgement how they are dealing with them. A circuit or a systems are known, that then how we can determine the value of output. To answer this question, George Boole invented a special algebra called Boolean algebra, also known as algebra logic or algebra of logics. It is a branch of mathematics which deals with the relationships of being variables. Instead of variables that represent numerical quantities as in conventional algebra, Boolean algebra handles variables that represent only two types of algebra propositions in them. So Boolean algebra has become the foundations of digital electronics. It operates with two logical states, 1 and 0, represented by two distinct voltage levels. Boolean algebra, simple interpretations of logic operators and or and not, has allowed the systematic development of complex digital systems as well as in them. Moreover, we discuss some basic logical operations and logical systems that implement these logical operations as well as AND operations. In order to understand the logic and operations, see the which a lamp is connected to a battery using two switches S and S2, S1 and S2 connected in series, considered as two inputs. There are four possible states of this circuit which are given below. When S1 and S2 are both open, the lamp is off. When S1 is open but S2 is closed, the lamp is off. When S1 is closed but S3 is open, the lamp is off as well as in them. We get the acknowledgement. The four possible combinations of switches S1 and S2 and the state of lamp are in them. It is clear that when either of the switches of both are open, the lamp is off. When both of these switches are closed, we get the profit. So the circuit which implements the AND operation is known as AND gates. Its simple is that AND gate has two more profits, has two or more inputs and only one output. The value of output of AND gate is always in accordance with the truth table of AND operations as well as in them. It means output of AND gate will be 1 only when all of its input are at logic 1 as well as, and for all other situations output of an AND gate will be zeros as well as in them. So in order to understand the logic our operation sees the circuit shown in them. A lamp is connected to a battery using two switches S1 and S2s in them. Moreover, two inputs, there are four possible states of these two input switches which are given below. When both S1 and S2 are open, the lamp is off in them. When S1 is open and S2 is closed, the lamp is on. As evident from the circuit, the lamp will glow at least one of the switches is closed in the language of Boolean algebra. So hope you like this video. See you in next.